Hello everyone, myself Revansiddappa Havaragi, Mechanical Engineering Department, Marathon Engineering College, Karnataka, India. Today we will discuss about mechanical properties of materials. The term property is a qualitative or quantitative measure of response of materials to externally imposed conditions like force and temperatures. Here, what do you mean by qualitative? Qualitative means that properties that are observed and can generally not to be measured with any numerical result. Right? It's not possible to measure. Then what about quantity? Quantitative is a property of a physical system which exists in a range of values corresponding with the numbers. Examples for this quantity means you can take a distance, mass, right? Those will come under the quantitative. Now, however, the range of properties found in different classes of different materials is very large. What it says? Range. If you take a steel, it's having different properties. Strength you can take, stiffness you can take, ductility, right? All those have it comprises in a very large extent. Now, here classification of material properties. A material properties can be classified basically four types. First one you can say it is a chemical. In chemical we have the compositions, right? Acidity is there, alkalinity is there, corrosion is there. This comes under the chemical. Then we come one more category is physical. In physical we want density is there, conductivity is there, right? Optical is there. Third one mechanical, where you have the strength is there, toughness is there, stiffness, ductility, malleability will come. In the fourth one, in dimension we have a size and shape. Today we will mostly focus on the mechanical properties. Now, what are the mechanical properties? Mechanical properties of material that determines behavior under applied forces are known as mechanical properties. It's a meaning, it's a behavior. If you see anybody comes and says hello, then you will say hello back to them. If anybody comes and slaps, say hello, then how will you reply? Hello? No, you will slap back and he will say hello. That is your behavior. Same thing. How the different types of loads and temperature, the behavior of the material comes outside. A sound knowledge of mechanical properties of material provides the basis of production behavior of materials under different load conditions and designing the components out of them. If any material if I want to use, right, to sustain a load, if I take it here, if I want to apply a load, it should not get bent. Then I should know which material I have to use. With what magnitude of load I am applying, it should not get bent. I should use that material. We should know, the engineer should know which material I have to use. Then, moving ahead, before entering into the mechanical property, just simply discuss about the stress and strain. What is stress? Experience shows that any material subjected to a load may either deform, yield, or break depending upon the three conditions. What are the three conditions? First condition is the magnitude of load. If you take it here, I am using this material. If I apply load, whether it go bend or doesn't bend, it should get bend or should not bend, depends upon the magnitude of load. Second condition is nature of material. Whether for this component I am using plastic, whether I am using a metal, whether it is ceramic, which one, depending upon the nature of the material. Next, cross sectional dimensions. So on what cross section area I am applying the load, that matters a lot here. Now, these things, cross-sectional area dimensions, we will see in the figure. Next, internal stress means what? Internal resistance which the material is called upon to exert to counteract the applied load is called as stress. You can say internal resistance to the externally applied load is called as a stress. And here you can say in this case, here this is the bar I am using. E0 is the cross section area, F is the applied force. Here I am using a tensile force. Then what is stress? Stress is equal to force upon cross sectional area F by A naught. See, this is the cross sectional area upon which I am applying the load as we discussed in the previous slide. Right? Now, two types of stresses are there. Right? First is tensile stress. Here, in this type, you are applying forces opposite axially. Then that is called as a tension if the elongation of the bar takes place. Right? Then that is next. Second is I am applying forces axially but moving towards each other. Then that is called as a compression stress. These are two types of stresses generating. Next, we will see what is strain here. Strain is the dimensional response given by the material against mechanical loading or deformation produced per unit length. Let's see. This is the bar with length L, right? When I apply load, when the material elongation takes place or deformation takes place by applying load, then see here, epsilon x is equal to delta by L. What is delta? Change in length. What is L? Original length. You can see there is a change in the overall length. Now, whenever the change in takes place, this material get added from where? Then you can see diameter material get reduced and that material get added in the length direction. So this is the strain. And here you can see for this change in length you can take it as a mm, original length mm, this will get cancelled. So for strain you don't have a unit. But when you come to the stress F upon A naught, what is force? Force is Newton. Then if I take A naught as mm square only, then the unit for stress is Newton per mm square. Next, first property, what we are going to discuss is strength. What is strength? It determines the ability of a material to withstand stress without failure. Here you can check an example. If a person try to break a pencil here, it doesn't fails. If it doesn't fails, it withstands the load. Then that is called as a strength. In one more example, you can see a person pulling a load. Then with the whatever the string he is using, right? That rope what he is using, which doesn't break, still sustains the load. Then that is called as the strength of that rope. Elasticity. What is elasticity? Elasticity of a material is the power of coming back to its original position after deformation when the stress or load is removed. Right? See here. Here in this bar I am applying load here. Right? When I apply a load, what happens? If the bonds get stretched here, these layers will get stretched. Delta change in the length has taken place already. This is the stretch. The next, here you can say whenever I remove the load, these will come back to its original shape and size. This whatever the layers are there, they will come back to the original shape. Then that is called as a elasticity. That property is called as elasticity. Then what is plasticity? The plasticity of a material is its ability to undergo some degree of permanent deformation without rupture or failure. See here, same example I will take it here. Here I am applying. Here this is the bar. Then when I apply a load, you can see the bonds or stretches and planes shear. There is a displacement will take place. So this is delta elasticity plus plasticity. Initially it entered into plasticity, then initially it goes to elasticity plus plasticity. That is there. So whenever I remove the load, see the elasticity has came, right? That whatever the plasticity, delta plasticity remain as it is, means planes still sheared. The displacement has taken place. So there is a permanent change in the dimension. Now from this curve you can see that this is elasticity. When it comes till here, it comes under the elastic deformation. After this there is a plastic deformation. Still, if I load continues applying the load, then it enters into the necking, then it becomes a enter into the zone of failure. Right? And then second property, stiffness. What it says, the resistance of material to elastic deformation or deflection is called stiffness or rigidity. Now, if what it says, elastic deformation of take, I will apply load. I apply load, it doesn't deforms. So then that is called as stiffness. This material having a stiff. Now, there is a difference between strength and stiffness. What strength is? Strength is hard to broke. It's hard to broke. What is stiffness? Hard to deform. Broke is different, deform is different. Right? We will see both examples. When you go for a glass, then you can see here, it is difficult to bend it. Have you ever bent any glass pieces? No, glass will never bend. But it is easy to break it. Easy to break. That shows that the strength is very low. But what about stiffness? Very high. Coming to next example, if you take a spring here, it is easy to compress it. You can compress a spring, but difficult to break it. Strength is high because you cannot break it, but it can be deformed. So stiffness is very good. Next property, ductility. What is ductility? It is the property of material which enables it to draw out into thin wires. Let's see. Right? This is the die and this is the workpiece. If I pull it, it becomes a thin wires. Whatever the electrical wires we are using, those are very thin. So that material, which material is using, that is having a ductility property. You can take a copper, good ductility property is having. Malleability. Malleability of a material is its ability to be flattened into thin sheets without cracking by hot or cold cooking. Right? Thin aluminum foils were using for food transportations. That time we were using those foils. Now you can see the example here. Gold is the most malleable metal here. Malleability, it can be formed with thin sheets there. Right? Here also you can see, you can get a thin sheets which we used to wrap the foods. Right? So this is the property of the material. Today this is all. We will see in the next class. Thank you.